Hi, I hope you're all doing well. Okay, so today we're going to go over trigonometric ratios. So you can see I have the objectives. These are the objectives for the whole unit. So our first blank here, a trigonometric ratio is a ratio of two sides of a right triangle. So you've seen for most of the year I've had SOHCAHTOA up on the side of the door of our original classroom. So, and on your calculators you have buttons that say sine, well they say sin, which is actually stands for sine, don't call it the sin button, cosine, and tangent. So you have the sine button, and on your calculator it's going to be abbreviated SIN. Again, stands for sine, it's not the sin button. There's cosine, and on your calculator it's going to be abbreviated COS, and then tangent. Okay, so these are ratios. They're ratios that apply to right triangles. Okay, you have sine. Sine is the ratio of the opposite leg to the hypotenuse. Okay, so we all know where the hypotenuse is. We've been doing that for a long time. You have the hypotenuse, which is opposite the right angle. So for sine, that's the opposite leg over the hypotenuse. Okay, so that's where the SO comes in. So this would be the SO8. That's why I had the SO on my door. Cosine is going to be the adjacent leg over the hypotenuse. So that's where the CAH comes in. That's the adjacent leg over the hypotenuse. Okay, that's the ratio. This kind of comes into when we learned about the similar triangles. These are constant ratios. Okay, these are always going to happen with certain angles in similar triangles. And then we have our tangent, which on your calculator would be the tan button. That's going to be the opposite leg over the adjacent leg. And again, if you remember on my board, I had the SOHCAHTOA. Okay, there's actually a little story that I'm not going to take time to tell you today, but we're going to use these to remember this, and you're going to see this in another video. Okay, so now just to spend some time, it's really important that you know which leg is which. Again, you have the hypotenuse, which is never going to change. Okay, that's always opposite the right angle. So if we start with this triangle right here, we have triangle FED. Let's find that right angle. So the right angle E. So you go across from that. This is always my hypotenuse. Now, which side is my opposite and which side is my adjacent depends on which angle I'm talking about. So your opposite side is the one that's across from the angle involved in the calculation. Your adjacent side is the non-hypotenuse side forming the angle used in the calculation. So it's kind of the one left over or the one used in the calculation. So let's first of all start by talking about angle D. Okay, so if I'm talking about angle D right here, if I want the side opposite angle D, okay, again, my hypotenuse isn't going to change. So for opposite angle D, I'm going to go across from it. So sometimes I take something to put it, I'm going across, it can't help form it. So opposite angle D, that's going to be side FE. Okay? So opposite angle D is FE. So then adjacent to angle D, well, we know this one's opposite for angle D. So the one adjacent to angle D is that one left over. Adjacent to angle D is going to be left over, and that's going to be DE. You can see right here how that one kind of touches it. Okay. So now if I'm talking about angle F, and since I'm kind of labeling them, I want to switch colors. For angle F, I'm doing angle F, and I'm actually switching the order here, sorry. The side opposite of that, I'm going to go across again. I was again like to kind of take my pencil or go across. For angle F, this one's opposite. So DE is opposite for angle F. And whereas adjacent is going to be FE. Okay, so I'm going to kind of circle these a little bit more. So the ones in blue are for that. The ones in orange are for angle D. So you've got angle D across from angle D. Opposite is FE. Adjacent is DE. For angle F, across from that is DE. And adjacent to that is FE. Okay, so we can do the same thing over here. My hypotenuse would be XZ, and then they would change accordingly. Now, one of the trickiest parts is once you identify your sides, the rest of it will fall into place. So there's going to be a short little video besides this one I'm going to have you watch where you're going to be practicing that. So now we're going to take some time and we're going to be practicing writing the ratios. So it says write the trigonometric ratios as a fraction and then as a decimal. So what I'm going to do over to the side, I'm going to write out that SOHCAHTOA. Okay, so this was the sine, which was the opposite over the hypotenuse. This is the cosine, which is the adjacent over the hypotenuse. And this is the tangent, which is the opposite over the adjacent. Okay, so sine is the ratio of the opposite over the hypotenuse. The cosine is the ratio of the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. Now, the first thing we need to do here, the first thing I always do is always identify your hypotenuse. So let's find the right angle. Here's angle L. So I'm going to go across. This is my hypotenuse. Also remember your hypotenuse is always your longest side. Okay, so they asked for the sine of angle J. So for angle J, sine is opposite over hypotenuse. So for angle J, I'm going to go across to find the opposite. So my opposite side is 60, so I need to put 60 over 61. So 60 over 61, that is the sine ratio. Okay, they also asked me to put that in decimal form to the nearest hundredth, so then you would just take your calculator for this, turn it on, let's see how well you can see that. Okay, that's actually not bad. So 60 divided by 61 to the nearest hundredth, that's going to be 0.98. So now we're going to do the same thing with angle K. It wants the tangent. The tangent, it's kind of scribbly over here, is opposite over adjacent. So for angle K, my opposite side, so for angle K opposite, I'll circle this, do the same thing I did, kind of color code. My opposite side for K, it's an orange, is across. And then this is my adjacent. So opposite over adjacent. So I want across, which is my opposite, the one that touches it, that's not the hypotenuse, the adjacent. Remember, your opposite and your adjacent switch depending on which angle it is. So for K, across from it is side JL, which is the 11, and the adjacent is the 60. So I'm going to put 11 over 60. Okay, and I'm just going to divide that. If you don't mind, I'm not going to show you the division on the calculator because I think you all know how to do that. So that's going to be 0.18. So now for the last one is asking for cosine K. If I go cosine here, I know cosine is adjacent over the hypotenuse. Well, I've already, for the orange is the adjacent, that's the side touching angle K. Remember, my adjacent would have switched if I was talking about angle J. But for angle K, my adjacent side is 60. So my adjacent is 60, side KL, 60. The hypotenuse is 61. So this is 60 over 61. So I'm taking 60 divided by 61. And you're getting 0.98. Now, you might notice that the sine for J and the cosine for K are the same thing. So, and that is because the opposite and adjacent switch. Okay? So, those are the ratios there. Now, moving on, sometimes you don't know the sides. They give you the angles. Okay, so you can see right here, they gave us two angles. So now what's important with your calculators, a lot of you are going to be using different calculators. You're going to want to check to make sure your calculators are giving you the same values. So what they're saying is this would help me get the angles here. What they're saying is if my angles, if you remember when we talked about similar triangles always have the same angles. So they're saying if the angle is 19 degrees, what would be the ratio of the sides? Now, I'm older than you. You guys all know that. Back in my day, there was this big trig table you would look up. But now calculators have trig values scored. Now, so what you can do is you're saying for 19 degrees, if I type in cosine, what it's going to give me is what the value would be for cosine for a 19-degree angle. What's going to happen if I take the adjacent side divided by the hypotenuse, because that's what cosine is. So I'm going to show you a couple different ways to do it in the calculator. And again, you're going to want to check because your calculator needs to be in degree mode. So if you have a calculator like this, you're going to want to hit the mode button. Go down, you see how it's in radian, hit degree and enter. Okay. So I'm going to hit, just go ahead and hit, in this case, the cosine button, and then 19 degrees. And in this case, you generally want to stick with 4 decimal places. So I'm going to type in 0.9455. Now, I know a lot of you might not have graphing calculators at home. Your scientific calculator should do the same thing. So, what I found, got my cell phone here, hopefully no messages are going to pop up. If you go to your calculator, if you didn't know this, my calculator was already in, okay, you're not going to actually, well, it's not going to show up. Well, maybe, there we go. My cell phone was already in degree mode, so yours should be 2. So again, you can just hit, well, we're doing cosine, 19 degrees. It's going to give you that same value. Okay. The next one, tangent 11. For an 11-degree angle, what is the opposite divided by the adjacent? So again, you would just type in, going back to this calculator, so tangent divided by 11 degrees, 0.194. I'm going to take one more decimal place. We usually go 4. Now, there's a reason we're doing this. Well, first of all, again, make sure you check with your calculator that you're getting the same values as me. If not, email me, show up to one of the Zoom sessions, and we'll figure out what's going on with your calculator. Now, the reason we're doing this is because you're going to use this to find missing sides.